Okay, here we go. Part 2 of chapter 17, and apparently I like to talk too much. Okay, so West Nile virus. I left off talking about this. It's transmitted through mosquitoes, found in lots of birds. It's transmitted often here in the United States to our horses. A lot of places keep chickens to monitor it. Around Disney, they have chickens in coops around just to monitor for disease in the mosquitoes, because the mosquitoes bite the chickens and then they test the chickens. The first human case was in 1937 in Uganda, 1990 here in the United States in New York, and it's spread quickly. Don't know really what happens when a human gets West Nile. I don't think it's a big deal. I think we can treat it, but we do have it here in Florida. Gotta watch those mosquitoes. They transmit lots of disease. So here's just a picture depicting some of our risk factors. Being around livestock can be an issue. Other human beings can transmit things. Having bad water, polluted air, bad food, and then of course wild animals can carry disease as well. So just some of our risk factors. Okay, so chemical risk, the chemicals that we are around. There's different categories of chemicals, and you should be aware of them. Neurotoxins are chemicals that disrupt the nervous system. A lot of your insecticides, lead and mercury can do this. You need to be very specific and know the consequences and the effects of lead and mercury. Those are two of the biggest ones. When we talk about pollution, a lot of these things will come back up, and we'll talk more in depth about them. A carcinogen is a chemical that causes cancer. Lots of things can cause cancer, we know, but you have to actually ingest them in very, very high concentrations or amounts for a lot of times. But tobacco is a carcinogen. Asbestos, which is an insulation material, is a carcinogen. And we'll talk about radon when we get to pollution and stuff, but that's a naturally occurring radioactivity from the ground. Okay, so carcinogens are chemicals that cause cancers, and there's a lot out there, so you got to be careful. Teratogens. Teratogens are chemicals that interfere with the formation or development of babies, embryos, fetuses in the uterus. Things like alcohol cause alcohol fetal syndrome. There are other chemicals out there that are teratogens. Your mercury is a big issue with hurting fetuses. They'll hurt the mother too, of course. Allergens are chemicals that cause allergic reactions. So your peanuts, your pollens, those kind of things. Endocrine disruptors. These are chemicals that interfere with normal function of hormones. Birth control pills, if you will, but of course you're taking those intentionally. But if for some reason you were to get doses of those and you were a male, that would be bad for you. We actually end up using endocrine disruptors a lot as a way to control pesticide populations sometimes. So that will come up later again when we talk about pesticides. Okay, dose response study. So sometimes we have to figure out how dangerous chemicals are. And a lot of times we use animals or plants to determine this. If we're going to talk about us, usually we use animals because it's not ethical to test chemicals on humans and potentially hurt them, at least not on purpose. So we dose organisms with the chemical to see what the reaction is. There's several different kinds of reactions or things we can do. We have LD50, which LD means lethal dose, and that's the concentration at which 50% of the individuals dosed died. So if you dosed, crickets, with different doses of a chemical, and then graphed it, the concentration of the chemical across the x-axis, and then the y-axis would be the percent death. where you have 50% death, you'd run over to your line, you'd drop down, and that's going to be your LD50, your concentration that would cause 50% of your sample population, your individuals that you've dosed, to die. Okay. Okay. ED50 is your effective dose. So if you're looking for a painkiller or something like that, you're looking for the effective dose. At what dose do your organisms start showing an effect of that chemical? So you would again dose them and measure the effect however you're doing that. It's a non-lethal effect, so you're not looking at anything lethal, but at what point are 50% of your population affected? So like with maybe your endocrine disruptors, if you're using them as a control for organisms as a pesticide, you would look for your ED50, your effective dose, so 50%. So you wouldn't want to dose one with any less than that because you wouldn't have enough of an effect. Okay, so here you go. Your mortality rate is up the side, what percentage of your population dies, and of course across the bottom is your dosing. You take your 50%, run it over to the line, drop it down, and that is your LD50. So for this would be about 5.4 units, whatever that would be on this. So we'll practice that in class, and we'll do LD50. Okay. That reminds me, we need to do the cell lab, don't we? There's some other things. I wrote another note about what I needed to do. Oh, never mind. Okay. Retrospective versus prospective studies. Retrospective studies monitor people who have been exposed to a chemical at some point in the past. So monitoring people who've smoked tobacco, monitoring coal workers who've been exposed to coal dust, monitoring people who put in asbestos insulation and seeing what happens over their lifetime. So it's not intentionally done. You're just following the people that this occurred to. Prospective studies monitor people who might become exposed to harmful chemicals in the future. So this might study children who live in a household where there's a tobacco smoker. This might monitor a X-ray technician who is going to be exposed to X-ray machines for a long period of time. So they're looking at potential effects from that exposure in their workplace. Okay. Synergistic interactions. This is one of the biggest things we need to be concerned about, and often you don't hear about this. The idea with this is that you can have two or more risks that come together and make one bigger risk or one more harmful risk. So there's different chemicals that are out there, and the fact is that if you mix them together, it could be worse. What is it? Ammonia and bleach. Like if you mix ammonia and bleach, it makes a toxic chemical that can seriously kill you in very short order. So we have things in our environment. Then if you have two or more of those risks, it can cause huge problems. If you have emphysema and smoke cigarettes, your risk has just gone way up. Or if you are a coal miner and have coal dust and then you smoke, your risk is gone way up. They don't just add together, they kind of multiply each other. So we need to be very careful about synergistic reactions, but the fact is, out in our environment, there's so many of those going on, we don't even know what the outcome of some of these are. They're really bad. Okay, so routes of exposure. How can you be exposed? Well, our water, our air, our food, our soil. Those are our big exposures for risks, chemicals, that kind of thing. And then, of course, fetuses and babies get their risks through their mother. Unfortunately, a lot of our toxins in our bodies end up being also concentrated through breast milk. So our children, unfortunately, get a high rate of toxicity through breast milk. However, breast milk still, even with some toxicity, is still much better for babies, if at all possible, than formula. So just so you're familiar, there is a risk, but it's very small. Okay, I think we've talked about bioaccumulation, biomagnification before, but bioaccumulation is when a chemical accumulates in your body over time. It builds up over time. It doesn't have a way out of your body. It just stays in your body and builds up and builds up and builds up over time. Mercury does this. Some of your vitamins, your non-soluble vitamins, can actually build up and be too high in your body and stuff like that. So, bioaccumulation depends on several factors, how you're getting it, how much you're getting, how quickly you're getting, the fat content of your organism, because honestly, most of the stuff is stored in fat. So if you don't have a lot of fat, you can't really store it. But it could cause a lot of problems. I'm sorry, I'm yawning. It's time for bed. Okay, biomagnification means that the higher you go up the food web, the higher the concentration of these chemicals in the organism is. So at the bottom of the food web, the concentration within an organism is relatively low. But as you go up the food web, that concentration is going to increase and increase and increase. And this is one of our problems, is we eat a lot of very top predatory fish, and they are very high in mercury. If you eat lower on the food chain, they actually have less mercury. Canned tuna has less mercury than like bluefin tuna or your better quality tunas in your sushi, because they're lower on the food chain. So that's biomagnification, meaning the concentration occurs as you go up. And I believe, did we do the M&M stuff, or was the other class did the M&Ms? We might have to do the M&M biomagnification at some point when we have a chance. Okay, so bioaccumulation versus biomagnification. Methylmercury. When I talk about mercury, actually what I'm talking about is methylmercury. Methylmercury is a digested, if you will, form of mercury. Plain old mercury doesn't hurt you. It's not toxic, it won't hurt you, that kind of thing, but it can easily in the environment change to methylmercury, and methylmercury is toxic. So it's taken in by the planktons, passed to the fish, it accumulates in the little fish are eaten by the big fish, it accumulates in the big fish, and so on and so forth until the human eats it, and what do you know, we get a nice dose of mercury. Actually, in the book I asked you to buy, and of course now I don't see my book. Where's my book? I'll have to find it. I was reading it the other day. You need to read Minamata, and I'll tell you guys that about tomorrow. Okay, talks about mercury poisoning. Minamata is a case of serious mercury poisoning in Japan. Okay, persistence. Persistence is when a chemical remains in the environment for a very long time. Some chemicals don't remain in the environment very long at all. Roundup now, some of the Roundup herbicides, they're like within 3 days you can plant your plant and it won't kill it. So that's not persistent. That breaks down rather quickly. Things like DDT, which is a horrible pesticide we used many years ago, stays literally in the environment 30 to 50 years. So we are still seeing major effects of DDT. And we'll talk about DDT when we get to pesticides. But literally, it can kill for 30 to 50 years. So you undoubtedly in that time, it's going to move because of rain and everything. You're going to have a lot of unwanted deaths and unintended deaths. Atrazine is an herbicide that we use here in the United States. Most countries have banned it because it's that bad. It's building up in our water supply and actually turning frogs into, male frogs into female frogs. Kermit is becoming Kermit, so it's pretty bad. Okay, risk assessment. The idea is you estimate the risk of something. A lot of times we think things are of a greater risk than they truly are. So often a risk assessment is done to see what the risk truly is. There's 4 levels to a risk assessment. A high risk, such as driving while intoxicated. Boy, there's a lot of typos in this PowerPoint. Or smoking. If you smoke a lot, it's high risk because you're probably going to get, pretty certain you're going to get lung cancer at some point. Low risk are things that the chances of them happening are pretty small, and the chances of them hurting you are pretty small, something like an earthquake. Some of the less frequent natural disasters kind of thing, earthquake, volcanic eruption, that kind of thing. Very low risk would be something that probably is not going to happen and really happens very, very infrequently in the historical record, like a meteor strike. And a mixed risk is something that it depends on your background or the occurrence. or where you live. So like a mixed risk would be of a lot of your cancers because